Hello everyone, welcome to Network Jungles. Today we talk about the OSI layer. So what is OSI layer? So OSI layer is the Open System Interconnected. It is developed by ISO in 1984. So it consists of 7 layers. Layer 1 application, layer 2 presentation, layer 3 section, layer 4 transport, layer 5 network, layer 6 data, and layer 7 is the physical layer. We can talk about one by one. First of all, we have to talk about the OSI layer. It contains 7 layers, as already told. For example, client requests some applications like web page, SSH, telnet, and any applications. It can be start from the application layer. That is the layer 7. And it goes to the presentation layer. It can take the format of the data. And section. It can maintain the section ID. And transport. Transport layer, it can be managed the TCP protocol or UDP protocol. Then network layer. It can manage the IPv4 and IPv6 address. Next one, data link layer. Data link layer can be managed the MAC address. Finally, physical layer. Physical layer can be managed the what type of signal can be transmitted. Finally, it can be transmit the data bits. So it be either electrical or light signals based on the medium. Again, it goes to the physical layer, data link layer, network layer, transport layer, section layer, presentation layer, and application layer to the server. So after data pulling from the server, it can be returned to the client. The OSI layer functions will repeat until the entire communications. Next, we talk about the application layer. It is the layer 7 protocol. It is an user interface which interacts human to work with the application service like FTP, SSH, SFTP, Telnet, SMTP, DNS, HTTP, HTTPS, DHP server, DHP client. Let's take the few examples. Here are the some of the examples of application layer. Here the format is data. So web browser can be managed the HTTP, HTTPS, and remote section can be managed the Telnet, SSH. Like file server can be managed the FTP protocol, and video section can be managed by the Zoom applications. These are the examples of application layer. Next, presentation layer. It is the layer 6 protocol which maintain the data representation format between the server and client, like image in the format of .gif, .png, and the audio format .mp3, like video .mp4, .avi, and a text .ascii format. It contains protocol which provides for data representation in common format between the application layer service, and it also do the process for the encryption, decryption, and compression, decompression while sending and receiving the data. Here are the examples of the presentation layer. Like the web browser contains the video in the format of .mpeg, audio in the format of .wav, and the text in the format of .ascii. Like the remote section can be used in the text format in the .ascii, and file server also the text format like in the ASCII code, and the video section contains the video in the format of .mpeg, audio in the format of .wav, and text in the format of .ascii. Next, we talk about the section layer. It is the layer 5 protocol. It is the software which can create, maintain, and terminate the section ID between the server and client. For example, you have to log in the bank website. If the page is ideal, then page will be automatically log out. So this will be maintained the section layer. It contains protocols which can provide the data exchange between the presentation layer. Here are the some of the examples of the section layer. For example, web browser maintains the section time between the web server and web client, and a remote section time between the remote machine and the client machines. Like file server, the section time between the FTP server and FTP client, and Zoom also section time between the host and guest. Next, we talk about the transport layer. Here it is called segment. It is the layer 4 protocol which data can be segmented into pieces from the center side and resegmented into the receiver side. So transport layer can be classified into two types of protocols: transmission control protocol and user datagram protocol. So these are the difference between the TCP and UDP. The protocol number 6 for TCP and protocol number 17 for UDP. It is the connection oriented protocol. It is the connectionless protocol. If the data is missing, it can retransmitted. If the data is missing, there is no retransmission. Here the acknowledgements of the packets for the packet transmission. Here it is no acknowledgements. It is the more overhead 20 bytes. It is the less overhead 8 bytes. It is reliable and unreliable. These are the examples of the protocols: HTTP, FTP, SMTP, and UDP protocols examples of DHCP, DNS, and SNMP. Here, the transport layer uniquely identifies the service or applications. It is the 16-bit. So 2 power 16 equal to 65,535 ports. So the ports can be classified into 3 categories: well-known port, registered port, and dynamic ports. So dynamic ports can be used for the computer. So registered ports can be used for the client applications, and well-known ports, it's also client applications. So here the sum of the transport layer protocols and port number, then application service. So TCP protocol in the port number 21, it is related to FTP protocol. The transport layer TCP, it is the port number 23, it can be used for the telnet purpose. Like UDP, the port number 67, it can be used for the DHCP server. Here the examples of the transport layer. So here the YouTube is loading. So the loading data can be used for the resegmentation process. It is done by the receiver side. The packet will be segmented from the center sides. Next we talk about the network layer. It is the layer 3 protocol. It is the software which can maintain the IP address, source IP address and destination IP address for exchange the packets. So IPv4 address is the 32-bit address and IPv6 address is the 128-bit address. It can be classified into 5 classes. So class A starting from 0 to 126, and class B starting from 128 to 191, and class C starting from 192 to 223, and class D it can be starting from 224 to 239, and class C is used for 240 to 255. So 127 is used for the loopback address. Next, IPv4 can be classified into private IP and public IP address. So public IP address can be used for outside of organization. It is the cost based. So private IP address can be used for inside of organization. It is the free of cost. So private IP can be classified into 3 classes: class A, class B, and class C. So class A in the range of 10.0.0.0 to 10.255.255.255, and class B in the range of 172.16.0.0 to 172.31.255.255, and class C in the range of 192.168.0.0 to 192.168.255.255, and 127 is used for loopback address. Here, IPv4 is a 32-bit address which can be divided into the 4 portions into decimal format. So 4 into 8, 32 bits. Here are the examples of the IPv4 address format. Next, IPv6 address. It is the 128-bit address which can be divided into 8 portions into a hexadecimal format. So 8 into 16 bits equal to 128 bits. Here are the examples of the IPv6 format. Here are the examples of the network layer. So source address, which is related to layer 3 protocol, and destination address, which is also related to layer 3 protocol. Here the sum of the examples of the format. This is the IPv6 address. It is requested from the source, and it is the destination address which is requested by the sender. Here the dynamic ports, which is related to layer 4 protocol, already told. So 443 is already told, it is the layer 4 protocol, it is the HTTPS. Here established time it is maintained by the section layer, it is related to layer 5 protocol, and these are the URLs, it is resolved by the DNS server which is related to layer 1 protocols. Next, data link layer. So here it is called frame. It is the layer 2 protocol. It is partially software and hardware which can contains the MAC address, source address and destination MAC address for exchange the frames. It is 48-bit address already told in the previous video, which can be divided into the 6 portion into hexadecimal format. Here the sum of the examples of the physical address. So first 3 portions is related to OUI, that is the organization unique identifier, and last 3% which is related to sequence number. Here the example of the data link layer. So it is called OR table. The matrix can be learned from statically and dynamically in the real-time communications. Here the example of the data link layer frame. It can be taken from the Wireshark. So it contains the destination MAC address, source MAC address, and IPv6 address, source and destination IP, and what type of protocol it is, and also TCP protocol also. So it contains the hexadecimal format. While the transmission it can be encrypted. Here it is source, encapsulation type, and how many packets. Next, physical layer. It is the layer 1 protocol. It is the hardware which can deals the data transmission either electrical or optical data between the two network devices. Physical layer may be classified into two type of categories: copper cable and fiber optic cable. Yeah, copper cable is used for electrical signal transmission. It is used for less than 1 kilometers. So Ethernet, fast Ethernet, and gigabit Ethernet, it can be maintained the different data rates. Like fiber optic cable, which is used for light signal transmission, which can be used for the several hundred of kilometers. So SFP. So SFP also can be classified into three categories: SFP, SFP plus, and QSFP. It can also maintain the different data rates. Here the what type of data can be carried in the physical layer. In the hexadecimal format, it can be converted to either electrical or optical based on the media. Thank you. I hope this video is useful for you. Thanks for watching video. Click the bell button to subscribe. Let's see you on next jungle video.